everybody joining today. I really appreciate you joining this presentation with me. I'm talking about how to determine the level of reliability for your service for your next outage. And the reason I chose this subject is lately I've had a lot of customers coming to me saying that they perform the same service again and again on the same equipment every time they're down, and they're not really sure if they need it or why they're even doing it, and if it's the right service for the application. So I thought this would be a good one to help out. What I'm finding is a lot of people that have damaged their equipment by performing the wrong service, or they didn't mitigate the problem that they had in the first place by performing the wrong service. So this is how to determine what to do. So the reliability services I'm talking about, just for the purpose of this presentation, is high velocity oil flushing, chemical cleaning, different levels of filtration, inspection, reservoir cleaning, varnish flushing, although varnish flushing is not really the best way of mitigating varnish. People are still doing that, so I have included it for this presentation. There's other methods of reliability services too, such as water lasing and possibly steam blowing. I'm not really going to cover those topics because these are the primary basic ones. So right now, for instance, one of the customers that came to me about this, every single time that they perform the service, they're doing high velocity oil, varnish flushing, followed by a high velocity oil flush and reservoir cleaning. And so, I mean, it's working for them, but they do it every time, and it's very costly. And then I've got some other customers, maybe some hydraulic systems. Every single time, maybe all they do is clean the reservoir, maybe some filtration services, maybe just clean filter the system. And so it's not always, they don't really know if it's being effective or if there's something else that they should be doing, or if they're doing it too often. So, and I apologize for this slide. I've had to change the, just when we got on so it would work with the system, I had to make my screen not as wide, and it's kind of messed up some of the information here. So the ones that always do the service, a lot of times they're doing it just because it does increase their mean time between failure and repair. So they are looking at those numbers and they know that it's effective, so they keep doing the same thing over and over. Others, they've just always done it that way. It was planned once upon a time and they just kept doing it and nobody's asked any questions. And then others are using oil analysis, as you should. And that is one of the steps I'm going to talk about, but there's some other things that you need to do as well along with the oil analysis. And then others don't do the services at all. And they don't because a lot of these services can be very expensive. They've not done any cost justification to understand whether it is effective and whether or not it justifies doing it. A lot of them are fear of damaging their equipment. Maybe they self-performed the service themselves and had a bad result, or they used an inexperienced service provider in the past and caused some problems. And some of them are doing it just from sheer lack of knowledge or a reactive maintenance culture. And then there's others that are doing the same thing over and over, and it's the wrong service for the contaminant. So they're not really doing themselves any good. They're spending a lot of money on something that isn't effective. And then others can't get the funding or the budget for the service in the first place because they haven't sold it to upper management by doing a proper cost justification analysis to prove the benefits that it will save them money if they are removing the contaminants from the system. And then others, it's just a matter of time constraints. Maybe they only have a few days that they're going to be shut down, and the service might go longer than the days they have planned. So what are we trying to accomplish anyway by doing these services? We're trying to increase the life of the equipment and the life of the oil. And in doing that, you want to remove contaminants not only from the oil, but from the system itself. Because if it's left in the system, it can actually it can reduce the life of your oil, and those contaminants can affect your critical components, so you want to remove them. So you have to choose the correct service for the contaminant. And here's an example of some of them. For instance, high particulate contamination would require something like a high velocity oil flush. Varnish, there's a lot of things you can do to remove varnish. There's some new products in the industry I really like, much better than varnish flushes, but people are still doing varnish flushing as well. For rust, you would want to use a chemical flush followed by a high velocity oil flush, because if you do a chemical flush, you're removing a lot of rust from the system, but you're putting particles in your system when you do that. So you really need to get those out as well and follow it with a high velocity oil flush. So the problems with the current methodology is, as I've said before, that a lot of these services can be very expensive, but they're really expensive if it's the wrong service for the contaminant, because if the wrong contaminant isn't removed, you can actually cause more problems. I mean, if the correct contaminant isn't removed. So in other words, if you're doing the wrong service, you're not going to remove the contaminant. For instance, a high velocity oil flush isn't going to resolve varnish. A varnish removal flush doesn't remove rust. System pumping flush, a system pump flush, which is using your system pumps to flush the system, you're not going to get high velocity and high flow enough to actually remove all the particulates, so only loose particulates are removed. Regular filtration only removes suspended particulates. Reservoir cleaning only removes stuff from the reservoir. Dehydration and filtration typically only removes the contaminants from the oil and not necessarily the system. So there's 4 steps that we recommend to go through when you're trying to determine what level of service you need. And it consists of oil analysis, reservoir condition analysis, system operating condition and parameters, and then reviewing all of the data from the previous steps. So when you're going through these processes, the first 3, you want a lot of documentation, and you want to look at all of these documents whenever you finally come to the conclusion. So that could include pictures, obviously all of the oil analysis results, and all of the information you gather about the system. So you want to start planning at least a year in advance. If your turnaround planning starts maybe 1.5 to 2 years in advance, then you'd want to start that process at least at that point. If it's 6 months in advance, you'd still want to start at least a year in advance, because you want to see at least a full year's data to determine the level of service you're going to need. So the first step is oil analysis. And when I'm talking about oil analysis, it is predictive maintenance. You're going to look at all of those parameters as well, but you're also asking some other questions that are not necessarily just predictive maintenance questions. These are questions about what is in the system itself, not just what's in the oil. And yes, you're pulling samples to find out what's in the oil, but you're asking questions such as, is the oil even worth saving? Because that's going to dictate the scope of work as well. What type of contaminants are in the system? How are they entering the system? Are they generating like wear metals? Are they introduced during maintenance? Environmental issues? Is there water in the system? Where is it coming from? What kind of water do you have? And ways to stop the contaminants in the future if possible. So the next step is making sure that you're getting good oil samples in the first place. So if they have oil analysis sensors, you want to see if they can share that data with you. You also want to get the information from the regular oil analysis samples. You would start the program the same way you would a regular predictive maintenance type of oil analysis program, with a sampling survey to make sure you're getting good samples in the first place. So you want to make sure that they're pulled from the proper location, the same time every time, with consistent methods, clean bottles, clean practices, proper labeling. And you also want to make sure that whoever is pulling the samples is very well trained. If you can use the same person for the same samples consistently, you're probably going to get a more consistent result. That's not always feasible, but it's recommended when you can. So most industrial applications, this would be the test slates that you would choose. And so that's the next step in your oil analysis program, is choosing the test slates for what you're looking for. And again, it's the same thing as predictive maintenance, except that you want to run an MPC, membrane patch colorimetry, and an ultracentrifuge annually at least, and then also 60 days prior to the outage. And one of the reasons is, of course, you're looking for varnish and varnish tendencies, but another reason too is if they have dictated that you do, or they want you to do a varnish flush, an ultracentrifuge will tell you if the chemistry that you're going to use is going to be effective. So if the ultracentrifuge number is too high, you know that you might have trouble actually removing all the varnish, and that is one of the reasons that varnish removal flushes can be unsafe, is that sometimes they leave varnish in the system or even the chemistry in the system, which is not a good scenario. So you also would use microscopic porography. And I know that that's something that's typically done for gearboxes mostly, but we like to see it annually and at least 60 days prior to the outage. Also because if you've got a lot of big particles, too big for spectrochemical analysis to pick up or to read, you'd want to have an idea of what's in the system, what's there, what it looks like, what the wear patterns are, because it can tell you a lot about what you need to do. And it can also tell you if you have rust in the system. So that's one of the reasons we perform that as well. So I'm not going to go over all of these trends here because it's of time, but you're going to look at oil analysis as a holistic approach, the way you would do predictive oil analysis, but you're looking at some other things as well. For instance, are you able to sustain a target particle count while the oil's in service? And if not, if you've tried dialysis filtration, is it effective or has it been effective? And if not, that's a good indicator that you're going to need a high velocity oil flush, or other things as well. Moisture, where's the water coming from? What kind of water do you have? Do you have rust issues? Has it been going on for a long time? So you're looking at a trend, not just one or two samples, because one or two samples aren't going to really tell you what you need to know. You're looking to see if it's going up. Have you had a lot of water issues, a lot of heavy particle issues? Is the oil oxidizing a lot? And you're looking at that along with your viscosity trends too, to see if there is a lot of oxidation in your oil. Are you keeping your antioxidant package intact? You're looking at all of the varnish trends. Excuse me, sorry about that. And then, as I talked about, what type of particles are you getting in your system? So the next step would be looking at your reservoir and your system and inspecting it. And again, you typically wouldn't take samples from a reservoir if you're doing predictive maintenance, but we're trying to figure out what's in your system, not just what's in your reservoir, because if you're going to take the system down, it's a good time to clean that system up and start out fresh. And again, one of the reasons for that is if it's in your system, it can affect the longevity of your oil, and it can also eventually start creating contaminants that move through your system that can harm your critical components. So we use a sludge judge or a bacon thief bomb. If y'all have questions about those, you can ask those after the presentation. But there's these items, you can get samples at different levels in the reservoir. And what you're doing is trying to see how much contamination is in the reservoir. You can see in inches or feet how much, what type. You're looking for bottoms, water, and sediment. And you don't necessarily send this to the lab unless you're looking to identify what the contaminant actually is. There are times you really want to do that. I'll give you for instance, there was a time that a customer had a failure and they were taking samples from the reservoir to try to see what was going on and what was in their system. And everybody in the room from the samples swore that it was varnish. It looked like varnish. Everything about it looked like varnish. But we went on ahead and sent it to the lab anyway, and it ended up being rust and there was no varnish in the system. So had we done something for varnish, it wouldn't have been effective and they could have had another failure. So keep in mind when you're doing these types of samples, you want to take it from several places in the reservoir, not just one, because of baffles. Baffles in the reservoir, if you just were to take one sample and it's clean, it might really not be indicative of what's actually in the system. And again, don't forget to document the test results and take photos so that you really know when you sit down and look at all the parameters, you really understand what the results were. So the next step would also be to understand the reservoir condition on the inside. If you can borescope the system while it's running, do so. If you can't, try to work with operations team to see as soon as they shut down and it's safe, if you can go ahead and borescope it then. Because what you're looking for are things such as bathtub rings for varnish, other signs of rust or contamination. We've sometimes seen coating from the reservoir flaking off into the oil, and it's a good time to plan to do something about it then, because you certainly don't want to leave those things in your system. Also, you can talk to some of the operators. A lot of times in some manufacturing facilities, they'll have instrumentation that measures varying temperatures and such as that, and they can give you a lot of good information so that you understand. It helps to understand also what's going on in the system and helps you to determine the level of service you need. So the next step would be to know the operating conditions. And so you'd work with somebody who really knows the equipment well and the history. The questions you're going to be asking are about high steam. Maybe they've had a steam seal leak, a lot of particulates. You want to know the history of trips, upsets, crashes, cooler leaks, seal issues, hydraulic control issues, filter plugging, all of those things since the last overhaul. And also if the equipment just has a history of this. You'd want to know if it's a carbon steel or stainless steel reservoir to determine what water ingression would do to the system. You want to know if they have a nitrogen purge, desiccant breathers. What are they doing to protect the oil? Have they had a history of leaking or rusting? Have they had slipstream filtration or water removal or varnish removal? And has it been effective? The next thing is I've got a form that I fill out with the customer. It has the type of cooler that they have so that you can understand some contaminants there that can enter the system. It has information on the type of oil. You're going to want to use all this information with your oil analysis too to see if they've been mixing oils, if it's the wrong brand, the wrong viscosity, if they bled the system and refilled the system. And then the last step is understanding, taking all of this data, understanding what kind of contaminants you have, the level of contamination, and then the method of mitigation. So based on all of those parameters, if you have a very light particulate contamination, you'd probably want to choose just some filtration or a circulation flush with just the system pumps, clean the reservoir, that sort of thing. If you have heavy particulate contamination or moderate contamination, we call it a level 2. You'd want to use high velocity oil flushing, calculating the proper Reynolds number to get a lot of high velocity and turbulent flow to really move all of those contaminants to the filters and the screens. You'd want to screen at certain places and check the screens to make sure that you've gotten the system clean, and use a particle counter as well. The system's not clean until the inspection on the screen show that it's clean, and you've got a particle counter better than what you would want your target particle count to be when the system is operating. You're using jumpers to jump the critical components and heat as well to get a good flush. Another one, this is our level 3. We've got combination flushes. So for instance, for rust, it would be a chemical flush followed by a high velocity oil flush. A varnish flush, you'd follow it by a high velocity oil flush too, because you're releasing particles into the system when you do these, and the chemical flushing and varnish flushing won't remove the particles. Or of course, instead of a varnish flush, there's some other methods as well. And then we have level 4. These can actually be done when the system's running, and it can help you to not have to perform some of the other services as often if you're doing these whenever you find moisture and particulates in your system. A circulation flush is for light particulates, of course, talked about that a little bit. And that is done when the system's down. You can't do that when the system's operating necessarily. So the conclusion is there isn't a one-size-fits-all solution to remove the contaminants. You really need to use a proper remediation based on the type of contaminant that you find and the level of contaminants in the system, how much is in there. You really need to have a lot of expertise in oil analysis, as well as the contamination mitigation methods. and the contaminants themselves in order to determine the right process to do, the right service for what you're seeing. And you need to use all of those oil analysis trends and proper methodology, visual inspection, and really understand the system, the history of the system to know what type of service you need to choose. So that's all I have on my presentation. I really thank everybody for joining in with me, and I'd like to open it up for questions.